In this video, we're going to go over the source code for the merge method. So let's take a look. This is just going to be one large method, right? There's no recursion here. It's all there. We've already talked about the parameters a little bit. So there's 5 different parameters. Basically, I have to have my A, right, my array I want to sort, an auxiliary array to do some temporary work in, and then a low point, midpoint, and a high point. And we said before, right, that this is the equivalent of saying I have an array like this, and I have these different designations for parts of it that I want to deal with. Okay, and the assumption around this algorithm, and you can actually see it on the first 2 lines even, is that these 2 parts are sorted, right? So whatever data I have here, it must be sorted. Otherwise, this algorithm will not work. This algorithm for merging will not work. My goal, right, is I want to basically convert this, right, into one, large array where everything is sorted, right? This is my goal. I want to have one large sorted array instead of having 2 little mini sorted arrays that are side by side. All right, so looking at my code, the first thing I do is verify those left and right sides are already sorted. Because if they're not already sorted, then, well, I'm not going to be able to do much. It's like I'll have a sorting problem from scratch again, right? And that's going to be a little bit, that's more work that I want to deal with. I want to actually merge these things together. I want to get a final, sorted result or ordered result for everything that I've been given. So I'm going to verify, right, that basically these 2 sides are sorted. All right, so I then start with 2 variables, right? One's called I, one's called j. So I is going to be a variable that starts over here. And j is going to be a variable that starts over here. Basically what they are is 2 variables that are going to walk along those parts of the array that we're trying to combine. So j walks along here, I walks along here. And you can see they're initialized in that way, right? So I is set equal to low, j is equal to mid plus 1. So they're both initially going to be the little arrows, little pointers, right, that are going to be walking along each index of that array one at a time. That's what we'll end up having them do. And they'll just traverse each of those 2 sides, right? Left side and the right side. All right. Next step, this is kind of our backup step over here. We're copying everything from A over to aux. Well, I guess not everything, but everything between low and high, right? Low and high is the region we're supposed to be working in. So everything in that region, we're going to make a backup copy of it. So we're going to copy it from A over to aux. Right? And then once we have that, then what we'll do is we'll basically copy them from aux back to A, but then put them into A in the sort order, right? Put them in the merged order they belong in. All right, so I have my backup data now. I'm good to go. Now I can start doing the merge. So this is all the merge code over here. So here's basically how it works. We have A. Right, this is A over here. And we have, there's aux. I'm going to actually, these are both aux. This is going to be a little bit of a strange notation, but these are both aux. And I have basically I and j. You can picture these each have a bunch of different indices here for all different things they're storing. So I have I and j. So how does this thing work? Well, the question is, right, is that given our 2 arrays I want to merge together, how do I know what to copy to A? Well, I want to look at it basically and pick whoever's smallest. So let's write in some data really quick here. So let's say I have one sorted array, which is, 3, 4, 7. Whereas over here I have 2, 5, 6, 8, something like that. Let's try to think of what we should do, right? If I want to get a single merged array out of this, what I would want to do is basically look at them. Well, I want to combine them together, right? But maybe what I would start by is thinking, hey, I can look at I and j, right? Well, let me look at the first elements in each of those arrays, because those first elements in each of those arrays, they are basically the smallest in their respective arrays. So if there's not going to be anything smaller in either of those, right, than the first thing in there, because I know those 2, the left and right hand side, are sorted. So I can look at them and basically say, hey, what is the smallest one in there? Smallest one in there, I can move you up. Right, so it's like here, the 2 is the smallest, so I'd move that one up. That means all of a sudden, my 2 is gone, and my j is now, try to draw j. My j is now indicating basically that second element in that array. All right. And I lost my border, but that's okay. So I've kind of consumed one element there. Now I can look at the fronts again, right? Look at I and j. I is 3, j is 5, where the values they're pointing at, right? Those I and j are going from 0 up until n, right? They're going one index at a time. But I look at kind of what they're indicating, I compare them to what's smallest, take the smallest one, move it up. 3 gets moved up. Right, so again, then in this case, right, my I gets moved along. I have 4 and 5. Well, 4 is the smallest, so I'll take another one from the top array, right, where I is. So 4 has been used up. I is now pointing at 7. Now I have 5 versus 7. 5 is smaller. Put 5. J moves over. Let's see, now we compare basically 7 and 6. 6 is smaller, so I'll take another one from that same array, that same right-hand side one, move the 6 up. Over here I have 7 versus 8. Well, 7 is going to go, over here, it's the smallest one. All of a sudden I'm out of stuff, right? I has walked through everything in that first array. It's been depleted. In that case, right, if I've used up an array, that means I just need to go to the other one and then move over whatever's there. Right? I don't have anything to compare to. I can just move it over. So yeah, I end up with my 8 over here, and this gets consumed. This gets consumed. Well, J ends up over there. So yeah. So the basic idea is basically say I have 2 arrays that are stored. I'm going to put them side by. I'm going to visualize them as being side by side. Really, in the array, right? They're side by side versus. Well, they're horizontally side by side instead of vertically side by side, which is what I drew. But I can picture I have 2 arrays. I'm trying to make this whole array that is the combined version of it. And I just always look at the frontmost element, pick the smallest one, and move it forward. Okay, that's my mechanism. And that's what the code over here is implementing. So basically, I start with this variable k, and k is walking along my alpha array, right? My A array. That's the thing that's basically the slot I'm trying to fill up, the slot I'm trying to give a stored element to. So in this case, where I need to start at low and go all the way to high, right? That's my region that I want to merge together. So what I have here, right, is I have a bunch of different cases. First case is I greater than mid. Basically, what this is saying is, have I used up this top array? So if I use up this array here, right, I drew it pretty large here, but you can think of, if I've gone through there, I've used the very element in there, well, then I don't need to look at it anymore. I just go and grab something from that array that's indexed by j, right, the right-hand side array. And that's what the first case is doing. So we're saying that if I is out of bounds, right, if we looked at everything on the left side, right, I is greater than mid, then, right, k is going to be assigned to aux of j++. So j, right, is basically our pointer to someplace in here, and the plus says, that's a post-increment operation. So the post-increment operation basically means that plus happens after you read it. So this line here is saying, okay, take the value at aux at position I and move it to a at position k. Right, so we're getting from that right-hand array and move it to where it belongs in the final output array. And then once we're done, do the plus, right? So move j forward to show that you've consumed that one element, right? The one element you copied over is no longer available. All right, so that's how that case works. The next case is kind of similar. So this is for j greater than high. This is basically saying we've used up the right-hand side. So once j is greater than high, then we don't have anything in that right one. That means we just want to put stuff in the left one. And so you can see over here, right? In this case, if we have my A array, right, my aux array, and I'm taking from the aux array in terms of the I index. So it's like I'm going over here to grab these, right, from the left-hand side one, and then move it over to the A array. So yeah, those are the top 2 cases, right? So this case basically left. So this case over here is left is depleted. This case over here is right is depleted. Okay, now these last 2 are kind of the main logic. So here, right, if we get down here, it means that both of these have elements in front, and we want to figure out how to combine them. We basically just compare them. So we say is the element at position j less than the element at position I? Well, if it is, right, if j is less than, well, we'll copy from aux at j to a, right? We're taking from that array. We're taking from the right-hand array, right, in that case. Otherwise, right, that implies that they were greater than, it's not less than, right? So we want to instead take from a. In that case, right, that's our else branch here, and so our else branch, of course, has the aux array, and we take out our element I and move it over to a, okay? So these are our actual comparison cases. So first 2 are if I use up either side, right, then I just take stuff out of the other one, the one that's not used up. Versus here I do the actual comparison, and it's just to check to see, okay, this is less than this one, then take it. Else, right, I have to take the other one. So this process repeats again and again and again. I go through basically all the elements between low and high, right? Low is my starting point, high is my ending point, and I combine together everything, right, in the aux array into the A array. So now the A array, right, has those elements in that bound, and they've all been sorted. Well, I should say they've all been combined. Right? We're not quite sorting, we're just combining them. We took kind of 2 stored inputs, right, and then combined them into one larger stored input, right? Our work, though, specifically, is really just to do that step of combining them or that step of merging them. Very last thing here is, of course, is sorted to verify that we've done our job properly, right, to make sure that the array we produce is indeed sorted. All right, so this is our merge algorithm, right? Basically, again, what it's doing, right, is it's taking 2 stored inputs and using them to produce one larger stored input. And this thing, right, was basically, it's part of the main merge sort, right? So in merge sort, we have these different steps, right? Division, conquer. This is our conquer, right? This is our conquer to basically take 2 things that are sorted and put them together and make something that's slightly larger that's also sorted, okay? So this is our conquer step. As a quick final note here, one thing you can take a look at, right, to maybe help trace the indices a little bit, is this trace. This is from the book, so you could probably have a paper reference for it too. this is kind of the flow of the calls to merge. And just to talk really, really briefly about this, you can see that we have basically all these little calls that are dealing with like little pieces of the array at the time, right? So it's like, hey, I need to do a merge. I'll have to do a merge, on these two and then these two. And then once I have those on those two, I need to do them over here, right? On them together, right? And then it's like, well, this whole thing, right, gets broken into a ton of pieces. This is sort of showing you like the second part. It's like everything's broken down. Now I need to combine stuff back up. And somehow the idea here, right, is that you're tracing where you're working with these little numbered indices, right? So these indices here, 0 to 1, right, are indicating, this over here, E to M, right? You have kind of this build-up step, right? The algorithm will go through. It calls merge a ton of times, right? Merge is what makes us, make stuff bigger, and it's kind of working from the bottom up at this point. So you did kind of the top-down step of breaking things down, and now you're going, back up. And so the indices, right, kind of track that, right? So the indices initially here was like 0, 1, here was 2 and 3, and then it's like, well, I need to combine them all. I need to combine, 0 through 3, right, which is this whole thing. And the process just repeats, right? So it's like here I got to do some mini merges, mini merge, slightly larger merge, even larger merge. And you can see right in the notation here at the indent is basically showing the innermost calls. So it's like this merge over here required these two that were above it. This merge over here required these two that were above it. This merge over here required everything that was above it. Okay, so those are kind of like subcalls. So if you want, right, you can take a look at that, kind of look at the indices and just see them change, right? Again, the idea is you've broken everything down to very small arrays and now you're building them back up and you're keeping track of where you're at just based on those indices, right? Where do I start, where do I end? Once I've dealt with two chunks, do another merge over those two chunks to bring them together and make an even bigger chunk. All right, so that's what we got for our merge algorithm. Hopefully that makes sense.